So here we are discussing the third statistical property of output response of LTI system, that is autocorrelation function of y of t. Y of t is called output response. No? So what is that we are finding? R by y of t1 comma t2. Okay. So R by y of t1 comma t2. What is the formula? It is the expected value of y of t1 into y of t2. Okay. Y of t1 into y of t2. So we know that what is y of t. So it is the output of LTI system. Y of t is equal to x of t convolution h of t. Okay. So that is why y of t1 will be replacing with h of t1 convolution x of t1. So you know that convolution will also satisfy commutative law, that is why it is also equal to h of t convolution x of t. Okay. So we write it as h of t1 convolution x of t1. What is the variable here? We have t2. No? So this can be written as h of t2 convolution x of t. Okay. Now we replace this with the convolution integral formula. It is integral minus infinity plus infinity h of tau 1 x of t1 minus tau 1 d tau 1 integral minus infinity plus infinity h of tau 2 x of t2 minus tau 2 d tau. Okay. Now we rearrange this integrals. It can be written as integral minus infinity plus infinity x of t1 minus tau 1 x of t2 minus tau 2, okay, h of tau 1 h of tau 2 d tau 1 d tau. Okay. So we know that expectation is applied to only the random process. So what is the random process here? X. These are the random process. So only to the x terms will be applying the expectation. So that this can be written as integral minus infinity plus infinity, integral minus infinity to plus infinity. Expectation we are applying only to x of t1 minus tau 1, x of t2 minus tau 2, okay, h of tau 1, h of tau 2, d tau 1, d tau. Okay. Now we have discussed that what is x. X is White's and stationary random process. So it will satisfy two conditions, that mean value of x, mean of x is constant, and autocorrelation function or xx is function of tau. What is tau? Tau is the time difference. Tau is time difference. Okay. So it is independent of t. Since x of t is White's and stationary, so what is this equation now? This equation can be written as expected value of x of t1 minus tau 1, x of t2 minus tau 2 can be written like this here. So what is this? Both are xx, so we can write it as rxx. Both are x. So we write it as rxx. What is that? We have t2 minus tau 1 minus t1 minus of minus plus tau 1. Okay. So here it is tau 2. Here it is tau 2. Okay. So this can be written as rxx of t2 minus t1 plus tau 1 minus tau 2. Okay. Now for example, if you take t1 is equal to t, t2 is equal to t plus tau. If t1 is equal to t, t2 is equal to t plus tau, then this equation, I'll write here, this equation can be written as rxx of t2 minus t1 will become tau. So it is tau plus tau 1 minus tau. This can be written as rxx of tau plus tau 1 minus tau. Okay. So this equation we replace with, this equation will be replacing where integral minus infinity to plus infinity, integral minus infinity to plus infinity. This we have discussed now. That's no. This is r x of tau plus tau 1 minus tau 2 h of tau 1 h of tau 2 d tau 1 d tau. Okay. So this is the equation for convolution integral of three variables here. Okay. So this can be written like this: integral minus infinity to plus infinity, integral minus infinity to plus infinity, r x of tau minus tau 1 minus tau 2 h of tau 1 h of tau 2 d tau 1 d tau. Okay. So this can be written as convolution of three integrals. Here you see for tau 1 we have minus 1. Here we have sign for minus 1 for tau 1. So one of this h of tau 1 we have, this will be having negative sign because of this negative sign. So it is integral. It is the convolution of Rx of tau convolution h of minus tau convolution h of minus tau convolution h of tau. So it is Rx of tau convolution h of minus tau convolution h of. Okay. Now if you observe this, what is that? R by y of T1 we have taken as T, no? T1, T2 as T1 plus tau. So R by y of T comma T plus tau is Rx of tau convolution h of minus tau convolution h of tau. So it is that it is function of tau. It is function of tau. So it is independent of t. So that what is this says? This says that output y of t is wide sense stationary. So what is the condition for wide sense stationary? The autocorrelation function should be function of tau. So r by y of tau is function of tau. So you don't have any t terms here. Okay. So it is not function of t. It is function of tau. So y of t is wide sense stationary random process.